I'm going to record this session, and then you guys have the data set. So if you want to, follow along afterwards while watching the recorded session, that will be great. I sent Rupesh all the data sets I'll be showing today. So this is basically the theme of what we're going to talk about. And not necessarily in this order, but this is sort of the overarching thing with the examples we're going to see. Big component is it's going to be about visualizing and describing data. That's basically what JUMP does. JUMP does that exceptionally well. So no matter what analysis we're doing, whether it's a simple analysis or sophisticated analysis, visualizing data is a big part of that. And JUMP does an amazing job at incorporating visualizations into the analysis. While we're doing analysis, we'll often do some kind of data manipulation. That's just kind of part of looking at any kind of data, and JUMP has a whole set of tools that allow you to filter data, switch out variables, and just do things that are almost the natural part of the way you analyze data, by swapping things out, hiding rows and columns, and so we'll see some of that as we go through these examples, and so that's good to see. I know there's a lot of engineering focus on this side, so we're going to talk about things like statistical process control, capability analysis, measurement systems analysis. So any of you involved in the Six Sigma process optimization world will be familiar with some of those tools. So I'm going to show you how JUMP handles that. I'm going to give you an example of a reliability analysis platform. We'll just do one little simple example so you can see that platform in JUMP. We're going to be building statistical models, evaluating statistical models, comparing the performance of statistical models to each other. And again, you'll see when we do this, visualization is going to be a big part of this. JUMP has this great way to take models, no matter how sophisticated, and create these tools to visualize it. Every one of these topics, we'll see how this goes and the pace of it, but we might get into some of these techniques, like how do you explore missing values and outliers. JUMP has a whole bunch of tools to do that, which can be very useful. We might get into some of the multivariate techniques, like clustering variables or observations together. Maybe we can get into component analysis. Again, we'll see how this plays out. And then I'll make sure to point you to JUMP resources and key resources that we have. Okay. In fact, actually, let me start with that, just so people know where all that they can find this help. Okay. I'm going to go to .com. Okay. So if you go to our website, .com, you will find a massive collection of resources that we have here for you to learn JUMP, not just for yourself, but also for your students. So a couple of things to point out. We have this thing called Community, and this is what allows you to go and search for topics, maybe post a question, see to follow discussions what other people are having. And so you can go into this community and see all sorts of discussions that are happening on different topics, and then you can type something in. So you can say, I want to search the community for doing correlation, and then a whole list of topics will pop up related to that. So it's a great way to sort of post a question, and it's a combination of JUMP folks responding to it, but it's also a combination of just users out there in our community, out there in the commercial and academic world. It gives you a chance to share data sets. You can contribute as well and answer questions. So that's a great way to get content, get information. Okay. Just going to go back to the home page here. There's a tab that you can look at called Learn JUMP. And if you go under that tab, you'll see a whole collection of things. So for example, we can list out all these sort of books that we have. Some of them are made by SAS Press, and others are outside publications, but these are books that feature JUMP. We have a collection of case studies So if you want to see examples of how different industries, different analysis types are using JUMP, you can use these in your classes. So for example, you can use these to find some good assignments for the students. So again, you can search by different things like different course types. You can search by different analysis types, and it comes with a data set and story fund. And so these are really great to give to your students for projects. We have a whole collection of recorded webinars, so kind of like what we're doing today. You can go to our webinars and you'll see a whole library of all sorts of different webinars that have been recorded. So you can search by different levels, like basic, intermediate, advanced. You can go by an application area. So you can say, hey, I want to look up things in quality engineering, and there'll be a collection of webinars focused on that. They're usually about an hour long a piece, but these are great ways for you to learn JUMP. Okay. We have a new course that we just launched called Statistical. And so this is a, what do we have? 1, 2, 3, 4, 5. It's a 7-module course that if you go through it, it's about 25 to 30 hours of self-paced learning. It's a combination of teaching statistical concepts, mixed with using JUMP and how JUMP fits into that. So this is everything for not only you guys to get up to speed, you can possibly assign some things to your students. I'm going to go to, we actually have one part of our website that's focused on academics. So these are similar things I was just showing you, like a learning library, webinars, course materials, books with JUMP. But here's where we're focusing on the academic audience. So, for example, clicking on course materials, you guys can get some content in here that you can use in your courses. There's some presentation slides, there's some data sets, we got instructor materials. So if you're teaching a topic, you can go here and see what we have, because you might be able to borrow and leverage some of this already existing content and slides and stuff that we have. And again, you can send students to some of the different courses or online courses we have. So I know we're going to do this section today, but please take advantage of what we have on our website. There's just an enormous amount of content. It's a great place to go to learn. All right. So with that, let's get started with JUMP. Okay. So when we look at a data set, we're not going to get too much into the details. We just want to get into the broad themes here. So I'm going to open that. Okay. So can you see the data set?
Yeah.
Okay. All right.
Yep, we can see it.
Perfect. Okay, so this is a data set where it's information collected on different states in the U.S. So you can see that column there, all the different states. And we have information on students taking things like the SAT verbal, SAT math test, which are what students here in the U.S. use to get into college. They take different standardized tests. And so we have some information about each of those states, and everything from things like the percentage of people taking the SATs in a particular year, average scores across the year, population of the state. So these are sort of all different attributes related to these states. And I'm going to just show you some simple tools in JUMP where we can visualize this data really fast. So a couple of the graphs that I'm going to make. I'll show the graphs first, and then I'll show you how easy it is to make them. So here's the graph.
Could you, 1 second, we're just turn on? Oh, let me hang up this one. No. Then we talk here on your
Hello.
Hello. You gotta try. Say hello again.
Hello. Hello. Kevin, can you hear us? I can, yeah.
Okay, so turn this up. Sorry, we're just playing with audio to make it Kevin, can you hear us?
I can.
Guess not.
Oh, maybe. Kevin, can you hear us okay?
Yeah, are you able to hear me well?
Yes.
Okay. Actually, you know what might be good, because there is kind of a lot of feedback coming. I'm wondering if it might make sense that you guys mute on your side and then turn it on when you have a question, because it's just, there's a lot of like feedback that it's hard to hear. No, looks like you might have just done that. You guys muted, right? Yeah. Okay. Perfect. All right. So all right, let's get back to the data set. So just to remind you again, this is data on information across different states in the U.S. We have different variables like the population size, scores on different standardized tests the students are using to get into college, year. So it's the standard, data set where you've got variables, columns, and rows, cases, right? So you got all these variables and you have all these rows, right? So this will be very easy to navigate, even if you're brand new to JUMP, because it's that familiar environment. And over on the left, right here, where I'm moving my mouse, those are all the variables. And you can do all sorts of things here. You can actually grab these and move these around if you want to reposition them. In fact, I can even grab a bunch of them and I can group them just to organize my work a little bit. So you see how I just collapsed all those into one. So you can do all sorts of things over here. In fact, I can even resize these things if I want to make it just, for the purpose of work. So in this panel, I've got all the columns listed. Down here, it's showing me how many rows, and if I started highlighting some rows, you can see that it's telling me how many rows I have selected. And up here in the upper left, that's where we're going to save what are called scripts. And so when we run an analysis, we can save that analysis to this data table, and then whenever we want to see it again, we just launch it. So I've got all these scripts saved over here on the left. So if I click on the little green arrow there, it pops up that analysis I did, which in this case is a graph. So this is the first graph I'm going to show you how easy it is to make, but I'm just going to show you where we're going to go. And this is a graph that is a map of the U.S., obviously, and each state is a different color, and that color is one of the variables. And I'll show you how in JUMP I can set this up so that I can swap out what variable is being used as the color variable. I'm quickly moving through them now. You'll see how it is. Another graph I'm going to show you is just a simple scatter plot, right? The classic Y by X scatter plot. Except what I'm going to do when I make this graph is I'm going to bring in two other variables. The size of the bubble is going to be one variable, and the color of the bubble is going to represent another variable, right? So this is a way to get actually 4 variables represented on one scatter plot. So I'm going to show you how we're going to make that. I can do the same thing. And again, this is some of the stuff that I think is really great about JUMP, because I don't think any stat software does it this good, is you can make a graph in JUMP like I have here, where I've got a classic Y by X scatter plot, and the size of the bubbles is one variable, the color of the bubbles is another variable, and I can set up things over here so I can swap the variable out. So here I am swapping out the color variable, and I can also filter and look at different years. Okay, and so why this is really great in JUMP is if you think about every possible graph you would make, right, with every possible variable used as the color or the size of the bubble, maybe what variables on the Y or the X axis, what group of years am I looking at? That's a lot of different graphs. And most programming environments and statistical packages, they make you make a graph for each one. Then you got to make another one, and you make another one, and then you make another one. But with JUMP, and you'll see this as we go across all analyses in JUMP, I can run one analysis, and then I can bring the variables and just swap them out and watch things change. So it's a lot more dynamic than creating a static piece of output. So I'm going to show you how to set those up. And then the other graph I'm going to show you for this particular data set example is called the bubble plot, which it looks like a classic Y by X, where the size of the bubble is one variable and the color of the bubble is another variable. But I'm going to set this up so that time is even another variable, and now we can watch the data and the bubbles change, you know, as in this case, it goes across the year. So that's the last one I'm going to show you. Okay. Now, though, Rupesh, now I'm thinking periodically you should turn the audio on if people want to say ooh or ah. Otherwise, it's dead silent. So, you know, if everybody's oohing and ahhing, you can let me know about that. All right. Okay, so I said the first graph I'm going to make is this graph right here, which is a map of the U.S. where the color is one of the variables. Okay. So the way you make graphs in JUMP is you pull up this tool called the Graph Builder. Okay, it's this platform, and JUMP is unique in the way they do this. So you pull up this Graph Builder, and basically sitting here is this blank canvas waiting for you to do something. See, most stat packages, when you want to make a graph, you decide ahead, like, oh, I'm going to make a scatter plot, or maybe I want to make a box plot, or maybe I want to make a histogram. You know, you decide that first, and then you make that graph. And if that's not what you want, then you try something else. Well, with JUMP, you build the graph, okay? So what I'm going to do is I'm going to drag a variable into this sort of canvas that's sitting there, and I'm going to drag this variable state. And now notice right when I grab it, all these different areas turn blue, and those are areas where I can drop the variable. We call them drop zones. So now JUMP has a bunch of maps stored in it, so when it recognizes the names of states, then it's immediately going to make a map of the United States, because that's what I dropped in. I could also drop in latitude and longitude. So there are things that are built into JUMP that's going to recognize what kind of map that you wanted in this case. Now they're just sitting there because that's all the information I gave it. So what we want to do is, well, let's bring in a variable and let's make it the color. So I'm going to pick up population, and I'm going to bring it over here, and I'm going to drop it. A couple places I can drop it on size, but what makes sense here is I'm going to drop it on color, and then I let it go. And so now that variable population is represented as a color from light to dark. So California, obviously, is the most populous state in the U.S., so it's the darkest, and then Texas, and you see New York and Florida, et cetera. Okay. Now, I might want to bring in and try a different variable. So I can actually try something out. You know, maybe I want to try, I'm going to pull that off, and maybe I want to put in the SAT scores, and I could bring that in. And so now I can see, oh, which states are scoring higher on average. Well, you can see that that's a little bit time consuming. So there's even another way I can do it, And basically what I'm going to do is I'm going to bring up this tool in Jump. This is one of my favorite tools. And this is everywhere in Jump. So whenever you're in analysis, so not just a graph like this, but if you're doing a sophisticated statistical analysis, I'll show you, we can bring up this thing called the column switcher. And it's going to say, okay, which variable are you thinking of switching out? Well, it's population. So I click that and I hit OK. And then it brings up all my variables and says, okay, well then what do you want to switch them with? And so I'm going to just click a bunch of these variables and hit OK. And now what happens is this graph window gets updated with, over on the far left, you'll see this column switcher. So this is what allows me to start picking different variables and then just watching, in this case, how the color is changing. So then I can get to maybe the one I want. That's the one I want, and I can hit done or save it out or copy and paste it to put it in a presentation or a report or something like that. But this allows me to kind of dynamically watch the graph change. And I just did it by bringing in all of these different variables and using them, swapping them out for the different density of the color. Okay. Like very, very simple graph. Now, if I want to save this to my data table, see if I close it, it's gone. But if I want to save it, I go in here and I say Save Script to Data Table, and then a little window pops up for me to save it. Now I already have it saved, so I don't have to hit OK. And then it will get added in this panel up at the top left in my data table. So whenever I want to see it again, I just launch it and then close it. Okay. So over here on the left, in the upper left, this is where your collection of analyses will be put together. And there's all sorts of neat things you can do, like you can group them together, right? So I can put scripts together, and maybe I have a name for those, because as you know, with a lot of analyses, you might do tons and tons of things. And so you might want to do, a few things here to sort of just kind of, organize your work, or, whatever you're doing to, obviously, keep this thing from just getting overloaded with so much content. Okay. Another graph I'm going to show you here is just how to make a scatter plot. Okay. And then I'm also going to bring in other variables. Okay. So I'm going to pull up that same graph builder platform. Okay. And then I just start dragging the variables into the different roles. So here I'm going to drag verbal into the y-axis. Now, since it's only one variable in the y-axis, Jump says, okay, I'll make a dot plot of that. Right? Kind of makes sense to do. If I want to see a box, click on the box plot and do to the box plot. If I want to box plot and the dots, I can do that. If maybe I want to see a histogram, I can make a histogram. Okay. So again, you don't think of ahead of time of exactly what you want. You kind of build it and watch it unfold. Now, if I grab a second variable, I'm going to grab this SAT map, and if I drag it and I'm going to drop it on this X roll, well, if I have a continuous Y variable and a continuous X variable, well, that must mean I want a scatter plot. And so it's going to make a scatter plot. And so there's a scatter plot. If I want to see what that looks like with a regression line put on it, I can click that on and off. If I want to see it with a little smoother line, I can click that on and off. If I want to see it maybe with a density ellipse, I could click that on and off. Maybe I want to see it with a little non-parametric density ellipse, right? So I can see where the bulk of the data is. Okay. So again, you're not making one graph, and if it's not what you want, then you make another one, and then you make another one. You're kind of interacting with it as you're building. I think it's not only do I think that's a really convenient way to be using software, but I think it really fits naturally with the way you analyze data. You're exploring data. You're dynamically interacting with it. It's not kind of a static exercise analyzing data. I think Jump really fits that. And in fact, when you do some of these things, I'm going to bring that regression line up again. Now, over here on the left, options will change based upon what selections you made. So since I fit a regression line, well, I've got options over here to say, well, why don't you display the R squared, or show me the equation, or put on a prediction interval. And so you'll see that some of these things get added to the graph if I want, and I can just simply turn them off. I also have a choice to fit different levels of different degrees of the equation if I want to do that. Okay. And then when you have the graph you want, you stop. But I'm not done yet, because I'm going to remember, this is what I want to create. I want to bring in color and size. Okay. So again, when I grab a variable, so I'm grabbing the variable population, as soon as I pick it up, again, you see all those drop zones. And there's different places I can put it, and I'm going to put it over here as size. And so now the size of the bubble changes based upon the population. I could have made that color if I wanted to. In fact, I could even do variables like this where I can group it. So, or maybe I want to group it this way, or maybe I want to group it this way. And so what it's doing is JMP is taking the population and saying, okay, I'll divide it up into 6 intervals, and then I'll make that same scatter plot of verbal versus math, but for each of those 6 categories of the population size. So maybe that's the way you want to look at it. But in this case, I'm going to do it as bubble size, so I'll drop it there. Okay. So again, notice I'm playing around with it to see which one I want, and then I'm like, aha, I want it to be that one, and then I let it go, and it's there. And if I want to redo it, I just pull it right off. Okay, I'll bring it back in. Okay. And then I want to bring in a variable to be color, so I can grab a variable, and now I can, same thing, I can do it. Maybe I want to panel it this way or this way, or maybe I want to panel it this way. But in this case, I'll do it as color, and so now I've dropped that variable in as the color. So now I've got those 2 additional variables. And just like I did in the example with the state, I can, if I want, bring up that column switcher, and then I can start swapping out variables if I want. And again, all from that same view. We're looking at this same piece of output, and I can swap that out. Okay. All right. And again, if I wanted to save this to the data table, I would do that. Or if I can also sort of close up the interaction part of it and just hit done. And now it's just a static graph. I'm not interacting with it anymore, and I can save it out that way if I want. I typically like to save it with all the features like column switcher and all the variables still accessible. So if I look at it again and I want to do something different, at this point now it's just that one graph, so I can't change anything now. All right. And there's all sorts of little things, like, for example, I can zoom in on the points if I want. Zoom out. Another thing that's great is I can move around the axes if I want by just grabbing it and moving them around. I can also rescale it. So maybe I want to change how this thing is scaled. I can just go in there and move it around to what I want. Or I can just double click on an axis, and then I have all sorts of options here, like defining the tick marks. I can define the colors. Maybe I want to put a reference line. I'm just going to throw something up here just to illustrate, but I can, to add a little bit features here. Maybe I want to put a line on this graph, and I can do that. And again, I can move this around. Okay. So even when you make a graph, you're still interacting with it in a way. I'm just not bringing in any other variables. Okay. All right. So as I go through this, I'm not going to make every single graph or everything I show you, because some of it's sort of that same exercise. I want to show you how easy it is. But here's that same kind of graph, that SAT verbal versus SAT math, so a standard Y by X scatter plot, where I've got the size of the bubble and the color of the bubble representing something, and over here is my column switcher. But I also brought up this tool that's really great in JMP called the local data filter. Now what this allows me to do is I can select different subsets of the data. So I'm going to go back to the data table just for a moment here. So for each state, I have different years. So 2002, 2003, 2000. You can see that, right? So every state that I have information on, I have it for different years. Well, I can bring that up here, and then this allows me to subset the data and see how that graph changes for that different subset. So if I wanted to look at just this data for 1992, here it is. Here's 1994. Here's 1997, 99, and so on. Or maybe I want to look at it for a whole group of years. So I might say, well, let me look at it from 2001 to 2004. I can highlight that. And so the only data that's put in that graph is that subset I define 2001 to 2004. And again, I can go over here and start switching out my column switcher because I want to look at a different variable as the color variable. Okay. So this thing that I'm showing you, you're going to see this a bunch of times in this session today, and you're going to even see it with more sophisticated analyses, not just a graph. Okay. And the last graph I want to show you here for this particular data set is this is similar scatterplot of verbal versus math, so simple y by x scatterplot. The size of the bubble is the population, like we've been doing. The color of the bubble is also a variable, but I also brought in time as a variable. And what that allows me to do is watch the location of those bubbles change as time goes on. Not only that, you might notice I have these bubbles grouped into different regions of the United States. So you'll see like Northeast, Pacific, South, Southwest, and so on. I can click on that, and now I can split it apart. Watch what happens. Now all the individual states come out from that particular region, and then I can bring them back together. Okay, split them out, bring them back together. And why I think stuff like this is great, I come from a traditional statistics background. I was in school about 25 odd years ago. And we stayed away from things like this. We did the classic statistical inference techniques, learning things like Anova and linear regression, but we didn't do a lot of visualization. I think at the time, professors thought it wasn't sophisticated mathematically enough. But what I think visualization does is it allows you to explore problems that are hard to define otherwise. I mean, how would you define this as a statistical model, this thing that I'm showing you there, how the states separate? In fact, I don't know if you're noticing this, but I'm going to click on another one. You'll see the same effect. You see how that's not a good one. Let me find another one. The South, I think, is the best one. Oh, Southwest is a pretty good one, too. If you notice what's happening is there's a set of bubbles that go up to the far right. I'm going to stop this here. See, there's a set of bubbles that go to the far right, upper right, and there's a set of bubbles that go to the lower left. And if you notice, the ones that go to the upper right are all light colored, and the ones that go to the lower left are all dark colored. Well, light to dark means the higher percentage of people who are taking the test. So what we're seeing here is in states where there are fewer people taking the test, they score higher on average. And states where there's a lot of people taking the test, they score lower on average. And so it's kind of logical if you think about it, because the people who, if it's a smaller proportion of people, you're getting more of the cream of the crop students. But if a larger group of people are taking it, well, now you're going to sort of average out a little bit lower because you're going to get students who will score high and students who will score low. Now, how would you describe that in a statistical model? I don't know. That's very, very complicated. But a simple graphic visualization like this allows you to kind of explore something pretty dynamic. Okay. So the theme of this particular example that I wanted you to walk away with is this platform called the Graph Builder. And we're going to see this in other examples too. And it's where you just drag variables into different roles. You come up here, you pick the different graphs you want, select some options. You can bring up things like the column switcher. You can bring up things like the data filter, and that allows you to create a dynamic graph that you can start interacting with. All right, so why don't we just pause for a moment and perhaps see if there's any questions before we close this example up. And then let's just see if there's any questions before we move to the next example.
I'm just double checking if there's any questions. Can you hear us okay now?
I can, yep.
Okay, good. I'm not seeing any questions. One comment though, everything's great. If you could just slow down a little bit on the clicks, there's a bit of a lag on our end. But otherwise, everything's great so far.
Okay, will do.
Thanks.
Okay. All right, perfect. Okay, so here's another data set that is about crime data in the city of San Francisco, which is where I am right now and where I live. So I'm going to study what crime is happening in my neighborhood. Okay, so we have all sorts of information about these crimes. We have things like the day that the crime has occurred, and this is all just on one month for one particular year. We have the time of day that the crime occurred. We have the day of the week. We have the category of the crime and all sorts of other information. Okay, and so there are, you look down here and see on the bottom, there is 9,134 records that we have in this data set. Okay. So I'm going to open up the kinds of things that I'm going to make here. And so this is a graph. This is a map of San Francisco. So it's a little street map. I'm going to make this one. And the colors on this graph represent the different neighborhoods, like the different police districts, we call it. Okay, so they have different regions. And every one of those dots is the location of that crime. So this is one of the graphs that I'm going to make. And kind of expanding that, that graph, I'm going to do it where I'm going to bring up the data filter, and it's going to allow me to look at all of the crimes, and then I can start subsetting by like different days of the week or different types of crimes. So I'm going to show you how to do that. And then the other graph I'm going to make is something here called a heat map, which I'm going to make a graph where the color is going to be the number of crimes, and I'm going to have one sort of panel for each day of the week, and then within that panel, I'm going to have on the y-axis the different police districts, and then on the x-axis, I'm going to have the different times of day. And then I'm also going to bring up that data filter so I can look at different types of crimes and watch how all this changes. So I'm going to make those three graphs. Well, it's actually only two, but we'll build up to it. Okay, so again, I'm going to bring up this graph builder tool, and you can start to see how easy it is. So again, it's this blank canvas sitting there waiting for me to build a graph. Now I have, in this data set, I have the latitude and longitude values. Okay, so that's recorded in the data set. So when I drag that in here, it's going to sort of create a latitude and longitude map, right? Simple y by x. Okay. Now you're looking at that. Now I recognize that's the shape of San Francisco because I live here, but I'm sure you don't. So what I'm going to do is I'm going to bring in a map. And I'm going to bring in a little street map. Click OK. And just give it a moment here to load up. And there is the locations put on top of that of the map. Okay. And I'm going to just, hold on. All right. So now what I'm going to do is I want to not have all the dots be just black dots. I want to incorporate color. And so the variable I want to bring in is this variable police district. So I'm going to drag this in, and I'm going to bring it over to, oh, hold on here, hold on one moment here. I just got to reset this one up. Okay, here we go. I accidentally let go of it in the wrong position, so now it's trying to make an incredibly complicated graph here. That's the issue here. All right. Okay. All right. So police district, I grabbed that and I dragged it into this color zone, and so now we have different colors for the different police districts. I made those dots a little smaller, but I can make them a little bigger if it's easier to see here. Okay. So again, you can just see this is sort of just defining those neighborhoods. Now, by bringing up the local data filter and having day of the week and category of the crimes, so I've got all these crimes listed. Oh, this is a neat thing with JUMP. When you're in some kind of window, in a lot of places, you can drag the size of these windows around, right? So if you can't see the whole list of variables, you can actually move these things around to make sure you can see the whole list. Some of these are a little long, so if I make it a little bigger here, okay. So I have all of the crime categories over in this panel, and I have all the days of the week in this panel, and so this is just that local data filter tool. I just launched that and brought up day of the week and category. So now I can subset the data in some way, and then the graph changes. So for example, if I want to look at, okay, I want to look at data from just Friday and Saturday nights, or Friday and Saturdays. It's okay, so here's just Friday and Saturday data. And maybe I want to look at a particular category of crime, like I want to look at just assaults. Okay, so now this is obviously much fewer dots, but now I have these dots represent only the assaults that occurred on Friday and Saturday. And if I wanted to, I could bring up another variable to use here. For example, I can bring up time. Bring up. So, okay, so now I've got 3 variables in my local data filter. I've got day of the week, I've got category, and then now I added time. And so notice what I can do is I can pick a time where I can actually drag this around. But I can go in and now say, well, maybe I only that happened on Friday and Saturday, and I only want to look at them that occur between 2 particular times, and I could type those times in, and then the graph updates. So once again, if you think of every possible combination of day of the week, category of crime, and time of the day, there is so many that in a traditional computing environment, like if you're doing this in R or Python or something, you got to make another one, and you got to make another one, and then you got to make another one. You got to make another one. Here, this allows me to click around, change the subset of data, and then the graph is changing as I'm doing that. And again, I can just pick different things. It's just taking a moment to load up the map, so it's a little slow, I think, on your end. All right, close that guy out of there. All right, so now the other graph that I want to show is sort of this this heat map one. Just give me a moment here, waiting for it to load the map. Hang on. All right. All right, hold on one moment here. I just got to move my home window. All right. No, that's small. Let me try to get this a little bigger. Okay. So this last graph here is this heat map. Okay. So same way I've been making the graphs, I'm going to bring up the graph builder. And I want to put in police district on the y-axis, time of day on the x-axis, and day of the week as a panel. Okay, so I'm going to bring in police district, and I put it on the y. Okay. Now again, as you do things, jump is like, okay, well, I'll just count up those incidences for each of those districts, because that's all the data it has right at that moment. So it sort of makes a little bar chart. I'm gonna turn it into a little heat map, and then I'm gonna bring time of day, drop that on the x-axis. Okay, so now it's going to have a heat map of police district versus time of day, and then day of week. I'm going to grab that, and then I got to decide where to put it. So I could maybe, if I put it up there, then it's going to panel it that way. If I put it over here, it's going to panel it that way. But in this case, I think I want it up here. So there's a easy to see panel for each of those 7 days. And then I let it go, and there it is. Okay. And along the same lines that we've been doing, I can bring something up like the local data filter and say, well, let me do the category of the crime, and then I can start clicking on different categories of crime and watch how those panels change and the frequency of those crimes on the different days of the week, the different times of the day, and in the different police districts change. Okay. All right. So this is just another example of hanging around in this graph builder platform and seeing what that graph builder platform can do. All right, I'm going to close this example up, and then let's just pass it over to you guys to see if you have any questions before I start another example.
Any questions? Any questions from anyone in the room? Yeah, we've got one question. So the question, Kevin, is one of the professors has some wind mapping data, solar mapping data, population data, and he was wondering is it possible to kind of combine those three data sets?
I think I understand that correctly. So for you said wind mapping, right? Like wind speeds and currents and all of that. Is that
Yeah.
Yeah.
That's correct. So, and it's all geographic data, so it's in different areas.
Yep. So as long as you've got, in this case, like a latitude and longitude coordinates, which I'm going to assume you do if it's weather data, you can bring that into that view. And I've even seen people do that with like ocean currents, and then it's dynamic, so you're watching it move. And someone was showing me this with like showing ocean temperatures changing over the past couple decades, and you're watching the colors move and change and ebb and flow across all these surface temperature measurements. So as long as you have some kind of X and Y, then you can drag that in, and then you're going to be able to make a visual of that. Oh, in fact, let me. I have something. I'm going to along those lines. This was an example I thought I was going to. That's a perfect lead-in. So this is a data set where 3 different variables, Y1, Y2, and Y3, are measured on these wafers. So I've got different wafer positions and different run numbers, but the location measured on that wafer, I've got an X and Y quadrant value, okay? So what that allows me to do is I can drag that Y and X into that graph builder, add wafer position and run number, and now it has basically a visual of where on that wafer it was measured, okay? And then once I do that, then I can bring in other variables like, well, what is the Y1 value? And now the color is showing me that, ooh, look, the darker values are kind of on this middle area of the wafer, and the edge of the wafer is light. Okay, and then I can start swapping out. I'm going to swap out Y1, and I'm going to bring in the others. And so now I can switch between Y1, Y2, and Y3. And notice what you're seeing. For Y1, there's a certain visual representation of the value of that variable Y1 on the wafer location. If I go to Y2, see, there's a different pattern. So I can see like, oh, the wafers score low on Y3 in certain wafers, and then they score high on others. Y2, and then here's Y3. And now I'm seeing, ooh, look at this. They're dark on wafer position 2 and light on wafer position 3. But for Y2, it seemed to be randomly spread around. For Y1, it seemed to be the location on the wafer. So this is just a little side thing that just popped in my head, but it's along that same question that if you have quadrants, whatever they are, they could be a shape of something. They don't just have to be latitude and longitude. They could be, in this case, the location on a physical object and where it was measured. Then I can build a map like that. So your question about wind, ocean temperatures, things like that, you can make a map of that and then have it dynamically change and swap out variables like I'm doing here. But I think that was getting at your question. Okay.
Yes, thank you very much. That was exactly what you was looking for. Thank you.
So let's move to some things that maybe are a little bit more. Let's move to things maybe that are a little bit more statistical in nature here. So let's see. Bring up. Okay. Okay. So this is a data set that I have on 31 different athletes. So each row is an athlete. I've got their name. I've got a picture of them. And the key variable is the oxygen uptake that athlete can perform, right? So that's measured on them. And we've got characteristics on them like their gender, their age, their weight, and then run time, run pulse, rest pulse, max pulse. Okay, so you can see we just got a bunch of different variables. And so what we're going to try to get at is, can these variables, gender through max pulse, can they help us predict oxygen uptake? Okay. Now, a couple little little neat things you can do in JUMP. If you look at the very top here on the left, you'll see there's this little, it's probably too small for you guys to see, but it's a little tiny histogram. If you click on that, what JUMP will do for each of these variables will actually just give you kind of a quick little summary of those variables. So I can see, for example, a little histogram. I can see the max and min if it's a bar chart. And I can even click on this. So if I click on males, then all of the males are highlighted there. If I click on females, then all the females are highlighted there. And you notice that it's all highlighted in every graph. So I can see where those data values are relative to all the other variables. Okay. So when something is selected like this, now I could say subset the data, separate that into a different worksheet. Maybe I want to do the analysis on the males and females separately. So this is just a quick way to get a really quick view of what the data is by just popping up a little miniature histogram. Now there's a little bit, better way to do that I can see with a little bit more information and content, but I just want to show you that that's a little quick view that JUMP provides. So I'm going to go into this Analyze menu, and this is where all of our statistical techniques are other than design of experiments. That's over here, a different menu, but the rest of these analysis and statistical techniques are here. So we're going to be looking at a few of these today. So I'm going to pop up this one called distribution. Okay. So the platform pops up, and it's waiting for me to put the variables in there. So I'm just going to grab all the variables, and I'm going to put them in this Y roll. And so you see they're all listed there. Remember, like I said, you can kind of resize this a little bit if you want, so you can see them all. Okay. And so when I hit OK, what JUMP is going to do, I have to keep on dragging the output up because it's putting it on my other screen, not the screen that's being shared. So sorry about that. It's coming from the bottom because it appears on my laptop, and then I pull it up to the main monitor here. Okay. So what JUMP does is says, okay, if the variable is a continuous variable like oxygen uptake, it's going to make a histogram. It's going to make a box plot, and then it's going to give a bunch of summary statistics. Okay. And I can change some of this information. So I'm going to hit this little red triangle next to summary statistics, and I can bring up and change which ones it shows. I'm just going to leave it as the default that's set, but that's how that's kind of why that's displayed there. And I can click on these if I want to change the format of how it's displayed. So if I only wanted to see it, one place after the decimal or something, I can change that. Okay. And you can interact with these graphs. I can slide them around. I could rescale them. So see how it's creating kind of different bins for the histogram depending on how I set that up. Okay. If there's a categorical variable in the data set, which there is, then it's going to make a bar chart and show the frequencies. So here you'll see that 16 of the 31 athletes, or about 52%, are females, and 15 of those 31 athletes, 48% are males. So now you notice when I click on one graph, you'll see two things. You'll see how it's getting highlighted in the data table behind, but it's getting highlighted everywhere else. So what this allows me to do is actually a little bit of exploration. So for example, if I highlight all of the oxygen uptakes that are high, those ones there that are large values, then I can see where those, let me grab a little bit bigger of a set here. So I just grabbed a whole bunch of ones that are large. I can see where those are across all the other variables. So in a way, I'm starting to get a sense, like, for example, notice the run times for all those people I highlighted with high oxygen uptake. That runtime tends to be low. Okay. See if I see anything else. That's kind of the main one. But you might also notice that there's more females than there are males that are with the higher oxygen uptake. I can highlight all the ones that are low and see where those land. So this is just a way that, even though it's just a histogram, even though it's just summary statistics, you can actually still interact with this to start seeing where values are in different other variables. Okay? So even though it's a one variable at a time analysis, in a way we're sort of making it a multivariate analysis by looking at where certain values are of some variables relative to values on another variable. Okay. Now, for those of you who are teaching some intro stat classes, then I'm assuming you're teaching things like the t-test, those basic inferential statistical techniques. Well, the way it works in JUMP is to do a t-test, you start off with making this sort of, this distribution analysis. Show me a histogram, show me summary statistics. And then from there, you say launch another platform to say do a t-test. So for example, let's say we're doing a t-test on oxygen uptake, or well, you can see over here we actually have a confidence interval that's shown over there. So we already have some inferential statistics. You click on this red triangle, and then all the options that are going to be under here are things that you might do with a continuous variable. So for example, I can make different plots. I can add a cumulative distribution plot, for example. Here is a t-test. I can test the mean. And so when I click on that, it's going to open up a little dialog box to say, okay, specify the value under the null hypothesis you want to test. Okay, so let's say we're testing if it's 50. And I hit OK, and then added to the section where I've got oxygen uptake, I've now added an area that is for a t-test for testing the mean. And I've got my p-values displayed there, along with the t-test statistic and other things that you might show, along with a visualization of what that p-value is. That little region is being highlighted over there. Now, every time you do something in JUMP, what you'll notice is there's little red triangles everywhere. And kind of like what we did to get the t-test, is those are things that you would do from that point. And so you can click on the red triangles to see what options are there. And so we have these neat little things, these little animations that we put up that are really great for teaching. So I'm going to bring up this p-value animation. And it's basically this tool. So if you're teaching your students about what a p-value is, I can start sliding over the distribution under the null hypothesis and watching how the t-statistic and the p-value changes as I move that around. Okay, so you'll see things like this in a couple different places where not only is JUMP good for doing a statistical analysis, but we have a couple of these things that we think really help with teaching, right? Because you can start illustrating, like an example, helping students understand what a p-value is and how that would change based upon changing the distribution under the null hypothesis. Okay. And then if you want something gone, you can just remove it, right? So I can remove some of these things, or I can even collapse them just to create more room if I want. Okay. So output, it's not like output, it's dynamic. You open and close things, you collapse things, you add to the output, you take things away. Again, which is I think a little bit different than most computing environments where you sort of create a piece of fixed static output and then you create another piece of output or another one. With JUMP, it opens up your analysis and then you interact with it by adding and adding new analyses or doing new things. So for example, and remember, you can resize these things if you want it bigger. So I'm going to make this histogram here a little bit bigger so you can guys see it on the screen. Okay. And again, remember, I can play with this. Okay. So I'm going to say, for example, fit a normal distribution to that histogram. And when I do that, it draws that normal distribution. And then over here, I will have information about that fitted distribution, measures of fit. So, for example, I've got measures of fit added here. I can do goodness of fit test, and every time I do something, something gets added to the output. Okay. right? So maybe I want to look at a quantile plot of the data. That gets added to the output. And again, if I want to remove it, I just remove it. And I can try all sorts of different distributions. I just showed fitting the normal distribution, but we have a whole host of distributions that you can fit, right? You want to change the confidence level in a confidence interval, you can change that here. You want to construct a prediction interval, or a tolerance interval, or a capability analysis, or test a hypothesis about the standard deviation. Maybe I want to look at a cumulative distribution plot, and so that gets added. So again, for your students, instead of saying, oh, I want to do a t-test, you don't go, oh, where's the t-test menu? You do it more like, how would you analyze data? If you had a variable, well, let me start off and let me make a graph of it. And so you make, I'm going to close this guy up. So you go and you make a graph of it. There's my histogram. Now you're like, okay, now I want to test the hypothesis about it. Drop the red triangle. You bring up that platform. You test the hypothesis. Maybe I want to see if a different distribution fits, and so on. And so you don't have to know that the thing is called the t-test. That unfolds as you do the analysis. But it's trying to encourage you, like, you got to plot the data. You should never not plot the data. So JUMP almost forces you to, like, start with the graph, and then you add, say, something more sophisticated, like, oh, now I want to do a t-test or something on the data, or fit distributions. But you start with graphing the data. Okay. I'm going to bring something up here. All right. So the other, remember the main point of what we were trying to do is to see how these variables, okay, these 7 variables may impact oxygen uptake. So we're going to do a platform we have called fit y by x. Okay. So y, of course, is the outcome response variable, and x is the predictor. So I'm going to launch that platform. Okay. Oxygen uptake is the y. Now this is only going to do a single variable analysis. So this isn't multiple regression. This is just going to be a single variable. So I'm going to grab all of these variables, gender all the way to max. Actually, before I do that, I'm just going to bring in gender. So if you have a continuous outcome variable and a categorical predictor variable or explanatory variable, well, that technique is one-way Anova. And so JUMP knows that's what analysis you're going to do because you have a continuous y and a categorical x. Okay. If I bring in a continuous x like age, well, then JUMP knows, oh, that's a bivariate simple linear regression. So it's going to run that analysis. If I had a categorical y and a continuous x, well, JUMP's going to know, well, that's a logistic regression. It's going to run that analysis. If I have a categorical y and a categorical x, well, that's a contingency table, like a chi-square analysis. JUMP's going to run that. So your students don't have to know what it is. They just have to know what's the outcome and know what's the explanatory variable, and then JUMP's going to make all the output. And then you can get into, what specific technique is answering a specific question. So I'm going to bring all of those variables in. So again, it's not going to do a multiple regression analysis. This particular, that's another tool. This is going to do one at a time. So it's going to do an analysis for gender predicting oxygen uptake, age predicting oxygen uptake, weight, oxygen uptake, and so on. So we're going to get 7 different analyses here, one for each of those candidate explanatory variables. Okay. So again, JUMP starts off with making a graph. That's what you want to do with this data. And so here's the graph of oxygen uptake and gender. Here's the graph of oxygen uptake and age, oxygen uptake and weight, and so on. Okay. Now there's no statistical analysis yet. I then grab that from the red triangle. So if I wanted to see the output in the standard Anova, okay, well, in this case, it's just 2 categories, so it's kind of the equivalent of a t-test. Here are all the options that I would do in this situation. So I'm going to launch the Anova platform. And then what gets added to that graph is now the standard piece of output you would see in analysis of variance, right? I've got R squared, I've got some hypothesis testing here, I've got the Anova table, I've got the p-value for the significance test, and that all appears because I asked for it, okay? I can even do, let's see, what maybe I can do is do, yeah, well, actually, I'll do that when I do the linear regression. Okay. And again, if you want to kind of keep the work clean, I can turn that off, turn it back on, or if I want, I can just kind of collapse that whole thing. And then if I want to see it again, I just open that up. Okay. For a continuous x, like age or weight or runtime, well, that's a linear regression. So when I click on this red triangle, there's going to be a different set of options here, right? Because it's expecting you to, oh, here's where you could fit a line. You're just testing if groups are different. You want to fit a line. So I can say fit line. And then now added to this output is it fits a linear regression line, shows the equation. Then I get all the information that I would get in a simple linear regression displayed here. Okay. Again, I can either close individual things up, or I can close the whole piece of output up. And then you'll notice there's a little red triangle here. So if I click on that, well, here's another set of options. Well, when you do a linear regression, you do things like, well, maybe I want to plot the residuals. Maybe I want to save the predicted values of the residuals. So if I click on plot residuals, now added, you see how it's working down as a column here, right? So I got this one graph we started with, oxygen uptake versus age. I added the regression lines, so I got all this output. Scrolling down, then I asked to see the residual graphs. So now here are all the residual graphs that would correspond to what you would do in a simple linear regression. And again, I can collapse those if I want, or open them up. Okay, again, if I want to keep the screen clean. Okay. And I can walk through and add those equations to each of those pieces of output. Okay. But again, you don't start off by running a simple linear regression. You just launch this Y by X platform, put the variable you want in the Y, put either the one variable or the many variables you want in the X, and it runs it, and the graph it makes is a scatter plot. And then you say, okay, well, now I want to see what the equation looks like. Now I want to see what the residuals look like. And then you just keep on clicking on those red triangles to unfold that analysis. Okay. Now, I'm actually going to do this another way. I'm going to do this inside of the graph builder. And so I'm going to put oxygen uptake there. And I'm going to put under here. And I'm going to bring up that picture we talked about. And what I do is I'm going to bring up, so I can start switching. I'm going to add the regression line. I'm going to put the, let's see, I'll put the equation, I'll put the R squared. I will actually turn off the confidence interval there, so it's just a line. And so now I can switch. If I want to do it this way, instead of seeing them all as separate analyses, if I do inside the graph builder, now I can just kind of swap out here and watch how all that changed, looking for the one with the high correlation, or looking for the one with what appears to be the strongest relationship. And I can even, I'm actually going to bring, I can bring gender in here and decide, oh, do I want to have a separate equation for each gender? Maybe I want it displayed this way. Maybe I want it displayed like this. Maybe I want it on top of each other like this, so I can put the two equations and the two graphs on top of each other, and now I can swap out. Okay. If that's not what I want, I can pull it off back to the original. So the graph builder, even though it's primarily used for graphing, can actually do some analyses, and that's where you can kind of explore where some relationship exists. You don't have the full platform of like making residuals and all of that, but this is another way to do it and to interact with it. Okay. All right, I'm going to just actually I'm going to save. I'm going to save doing. Oh, you know what? No, I think I will do it with this. I'm going to do multiple linear regression with this. Okay. So now let's say I want to not just fit one variable at a time and see how that does. And now I actually want to. I'm just moving around some windows here because I'm trying to figure out why. I'm hoping it could just launch on the screen I want. I have to manually move it every time, but I get two computer screens up here. Okay. So if you want to do a multiple regression analysis, it's not under this fit y by x, but we have this general platform called fit model. So I'm going to launch this fit model platform, and this is where it's going to not just allow me to put one x in, but many x's at a time. So oxygen uptake is y, and gender through max pulse are going to be all the x's. Now, if I wanted these just to put in main effects, then I would just do it like that, okay? If I wanted to do, let's say, all the interactions as well as the main effects, then I can say put in, now if you notice, now I've got every possible combination of those variables, not just main effects, right? So now you can see what else I have in there. So you can sort of decide what kind of terms do you want to put in. I can put in quadratic terms if I want, or maybe I'm just selecting individual ones. So I might say, for example, well, I want the main effect of gender, and let's say I want all of these main effects, age through max pulse. But maybe from sort of some of that initial exploration I was doing, is well, maybe I just want age and weight interaction, so I can just put that one in, or maybe I want rest pulse, and I want that, let's see, I'll do rest pulse, and now let's do to degree. Oh, that's not doing exactly what I wanted it to do. Okay, so you see that I'm trying to add individual terms in here, one at a time, as opposed to putting everything in. But let me take some of those out. Okay, so now I can decide. Well, actually, you know what? I'm gonna put in. Let's see. Let's do everything actually. So the routine I'm going to run is, instead of fitting a model with all of these terms, I am going to choose to do stepwise regression. So if I hit run right now, it's going to fit a full model with every single thing I put in there. So you've got all the main effects and you've got all those interactions in there. Okay. But what I'm going to do is I'm going to launch the stepwise routine. And now what JMP does is it opens up this platform that says, okay, let's build the stepwise regression model. And so I can decide the criteria I'm going to use. So let's say I'm like, okay, let's use the p-value criteria. I can decide what the p-value for entering or leaving the model is. Do I want to do forward selection or backward selection or stepwise that lets terms come in and out? Now, I can do this one at a time. So Jump will search through. So if I hit step, it comes through and says, okay, runtime, that's the most significant variable. That's the one with the most significant p-value, the highest correlation. It brought that one in first. Okay. Then the next step, it starts bringing others in. Okay, so now it's bringing in the interaction gender by age. So now it brings in the two main effects and the interaction. Okay, I could also just hit go and let the whole routine run, and then it's just going to add variables in and then stop. So it shows you with the check marks the list of the variables it brought in, and the ones it has not brought in is not checked. I can force them in if I want. So I can say I want that one to be in there, and I can sort of force it in. Or I could decide, looking at these p-values, that, you know what, I'm going to take one of these out. I don't want that in there even though it met the criteria. So you're kind of interacting with building this model. And then when you're done, you're like, okay, this is the model that I want. Then I say, basically, go ahead and make the model. So now it's only set up with the terms that I've selected in that stepwise routine. And now it's going to run a multiple linear regression analysis. Okay? So that output's going to look a little different. So I've got, here's the plot at the top is showing the actual oxygen uptake values versus the predicted. So it kind of gives me a sense of how well my model is doing at predicting, right? Those things should be highly correlated. Okay, so I can see that. I've got a summary table sort of displaying the sort of significance of each of those values or the importance of each of those values. And I can take things out too. I can, at this stage, I can remove or add variables if I want. So even though I've built the model, I can start doing some of that even here. So I can say, well, I'm going to take out this weight variable. Well, actually, I can't because it's in the interaction. But I can start pulling things out if I want. Residual graphs, Anova table, okay? And again, you can kind of expand or collapse these if you want to keep the output clean, or just look at key things. And then under the red triangle, there's more things you can do, okay? So I'm going to, this is one of the tools I like the most. I'm going to bring up this profiler, okay? So now what Jump does, let me just make this a little bigger so you can see it, is now it has a visual representation of that model. Okay. Now I can see the equation too if I want. So if I want to see what the regression equation is, there it is displayed. Right. But what I think is a lot more fun, I think more useful for students, is when you have a visual representation of it. And so now here's each of those coefficients represented for each of those variables. And I can start just dragging it around and noticing how the prediction changes. Now, you might also notice you're starting to see the concept of an interaction, right? So this is great for teaching students, right? Because you can say, oh, what is an interaction? It's, well, when I change one variable, the effect of the other variable changes. And so you can start to see those that have an interaction and those just have an effect. The effect isn't changing, just the location, right? So I can start kind of moving those around. You'll notice how the confidence intervals are changing. And again, I can interact with this. Move this around, okay? And then under that red triangle for the profiler are going to be different options, all related to what you might do at that stage. Okay. Now, in addition to just looking at single variables, I can choose to look at a profile. Okay, so I can say look at like a contour plot. So I can look at it in 2 dimensions. So I got weight and age, and I can see, you know, where those, I can move the contours around. I can even define a region. So I can start bringing in a region. I can swap out these variables. So it happens to be weight and age, but I can say, well, let me see how that contour plot looks with runtime on that axis. Or let me swap out this one. Okay. So again, the main theme I'm hoping you're picking up here is when you're using JUMP, it's not a one-time analysis and it's a fixed piece of output. And then if you want to try something else, you run a different one. And then you want to try something else, you run a different one. You're interacting with it. And I think, again, it's a great way for analyzing data in practice, but I think it's an awesome way to teach because I feel you learn and students learn by you change something and you watch what does or doesn't change somewhere else. So like with this profiler, I can say, well, let's look how the relationships look for the females. And I switch over and watch the relationship. Oh, let's look how it looks for the males and then watch that relationship. I can add, let's see what else. Let's do a surface profiler. So now I can add a surface plot. Okay, and again, I can swap out which variables I'm showing. Okay, I can move around, fixing different values. So now age is categorical, so that's why, oh, here's the interaction. You can totally see the concept of interaction here, right? The relationship for one gender with age is different than the other gender. Okay, I can even, let's see, what else do I got here? I can put in and do something, one thing I'm looking for. I'll show that in a different one. Okay. So again, it's one thing to make a surface plot. It's another thing to be making surface and contour plots and then playing around with them and interacting and then watching how all that output changes. Now, remember how when I was showing you the column switcher and the data filter, how the graph was changing? Well, I can bring up that stuff here as well. So if I bring up the data filter, so let's say I'm going to pick age. Now, I can start changing the age, and all of this output is going to change. Now, I'm just going to open up a couple of these just so you'll be able to see it. So right now in this data set, I've got age athletes from age 38 to 57. Okay, and again, I've got all this is the full multiple regression model with all those variables and interactions. If I, let's say, well, I only want to look at people who are over 40. When I do that, take a look at the output. It's all going to change. Okay, you saw that change, right? Right, so go back. So as I pick different values here, everything's changing. The residual graph, the R squared, right? The profiler, the contour plot, the surface plot, all of that is changing as I'm filtering the data. Okay, so again, I don't have to go, subset the data, create a different worksheet, then rerun the analysis, and then try to swap back and forth to compare what's changing. I can do that live right here in the output. And again, not only do I think that's great for analyzing data, but it's great for teaching, right? That's kind of how I think when students see the data come alive, when they're interacting with it and they watch something changing or something not changing as they play around with something else. But notice that as I'm sliding that around for age, all the outputs changing to be consistent with that. So, and I get excited about it. I can't say that enough how cool I think that is for analyzing, but teaching statistics, especially now because we deal with so many multidimensional problems.
Hey, Kevin.
Yep.
We're losing the audio a bit. Let me try something. Let's see if this will work. Let's try. All right, can you try speaking, Kevin?
Okay, can you hear me now? Can you hear me? 1, 2, 3, 4, 5.
No, let me try calling in again. Give me 1 second, because the audio is a bit rough. 1 second. All right, Kevin, can you try again speaking?
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That any better?
Yes, it's working again.
Okay.
Just to give you a little time update, the professors, or some of the professors have an event to go to at 1:30, so we have another 45 minutes, say, after to go, and then that should be good. Does that work for you?
That works perfect. All right. So I'm going to close. All right. You can hear me now, right? You're still on?
Oh, yeah. Yeah, it's clear. We can hear you now.
Okay.
Very well.
Okay, so I'm going to open up a new data set. And by the way, the audio was cutting out when I was finishing that last example. All that I was saying is, and I was clicking on different things kind of rapidly, but just trying to show that with JUMP, you don't do an analysis with a particular data set, get a result, and then when you want to do something different, you do something different. You're inside of the output, playing with it, interacting, swapping things out, filtering data, and then you watch all the output change. So I just was emphasizing that I think that is just an awesome way to teach. So you can really help students see it dynamically change. It really brings the data alive. Okay, so in this data set, this is information we have about 20 different U.S. cities. Okay, it's irrelevant what the variables are. Just know that we have nine different variables here. Okay. Now you might notice one of these columns is a little bit of an image, and I'm going to just drag it to make it bigger. So that's a picture of that city. Okay. So JUMP allows you to bring in an image as a data value in the data table. Okay. And I'll show you in a moment why that's useful. So with a data set like this with 9 different variables, a nice way to look at is, well, let's just kind of start plotting the data. Let's just look at how it looks in this multidimensional sense. So JUMP has a platform called multivariate. We're going to launch it. I'm going to put all those variables in there. Hit OK. And JUMP says, okay, well, you've got 9 different variables. I'm going to look at all the possible correlations between those 9 variables. So you see a correlation table at the top. Then it says, okay, well, I'll make all the possible scatter plots that you can make with those 2 variables. Oh, by the way, I've got these things colored here. Let me turn that off. Okay. So you saw how I just had the points colored different colors. Let me I shut that off now. Okay. So now it's got all these scatter plots of every possible combination. Remember, you can play with this, move this around. I can add features to this, so I can fit, for example, an equation on there if that's what I wanted to see. I can fit a density ellipse on that. I could do maybe a non-parametric density if I want. Okay. Just different kind of ways to view that data. Now again, this is only two-dimensional that I'm looking at this, but it gives me a chance to see where some observations are, see if there's any unusual observations. Okay. But I'm going to do a 3D scatter plot instead. So I'm going to put all those variables in there. Click OK. Just got to bring up from my other screen here. Okay. And here is a 3D scatter plot that I can now interact with, rotate around in different directions. Okay. Now these are just three of the 9 variables, but I can start changing them. So I'm just clicking through and swapping out. I can either manually swap them out here or here, or I just click through and it's just going through every possible combination for me. Now I'm going to just I'm going to use the graph builder. I just want to make this large. I'm going to I'm just making this large so I can show you that I mentioned that we have images in this data table on the column. Well, I've set that up so that an image is a label. So if I float over a point, now you see that that picture comes popping up with that point because I've attached that image to that row. Right. So I didn't do it when I was showing the athlete example, but I had little pictures of the athletes, and next to those points was the same thing. If I floated over those points, little pictures of the athletes would pop up. Okay. So this is really interesting, and I've seen a bunch of examples where people really played this in an interesting way. There was a cell biologist, I can't remember what university he was at, that he was showing me something at a conference where he had it set up so that images of those cells, done through a microscope that he had saved. So when he floated over a data point, he would have sort of those microscopic images that he took that was related to what that data point was. That I thought was really interesting. I've also seen a person in a manufacturing environment where they have defects, and they would take a picture of what that defect was. Like maybe if there's a little part that there was like a little wear piece to it, or there was a little crack in it, and so they would take pictures of it, and so attached to the data values when looking at a graph were pictures of that. So I don't know, it's a neat little thing that JUMP does that I think can be quite useful. Now, the analysis I did with this data set was to try to cluster these 20 different cities. And I don't know if you guys teach clustering in any of your courses. It's one of those topics that when I was in school we didn't cover too much, but now it's just used everywhere. It's just so popular where people say, hey, I've got a bunch of data, I want to group like things together. So JUMP has a couple different clustering routines built in. So I'm going to choose one of these clustering techniques called hierarchical clustering. Put all the variables in. Hit OK. And what JUMP does is it creates what's called the dendrogram. I don't know if you're familiar with this graph. For those that aren't, kind of going from left to right, basically what's being plotted is how similar things are, and they get grouped together when that closeness or similarity exists. So, for example, if you look at this graph, you'll see that Charlotte and Nashville, you can see this how they group right there. So they group pretty, pretty early on, showing similarity. Or San Francisco and New York kind of group together. Okay, Boston and DC. And so you're watching sort of that process of how similar things are. And if you look at, I'm going to pull up the 3D scatter plot at the same time here. All right. So, for example, a city like Charlotte and Nashville are grouped together, and if I sort of look at the 3D scatter plot kind of to illustrate that, you can see how they're close. Those are those 2 points that are large that I've highlighted. Okay, and even if I move through different combinations of variables, you'll see that they land pretty close to each other as I move around. Okay, as opposed to picking two cities that are, say, very different than each other, like Dallas and Atlanta, and you see that they're further away from each other in this graph as I click around. You can see how far those two points are. Actually, and I should probably change that to a color because it's a little hard to see. Okay, so you can see how those points are further away. So this clustering analysis technique is kind of a neat way. Turn off the color here. So this cluster analysis technique is a really neat way to sort of see which things are like each other. And there's all sorts of little options you can do in here. I can start, let me pull up the one I had already done here. I'm just going to show you more the complete output here. So I ended up I wanted to color the different points. So I colored the different clusters, different colors, so I can sort of just see them a little bit easier. So there's just some different displays. So, actually, I'm going to pull up this. Something I didn't mention is everything is connected in JUMP. Let me grab one more thing here. We'll grab multivariate. Okay. So I'm gonna have three separate pieces of output on the screen here. Okay. So I've got a 3D scatter plot over here on the right. I've got the results of a cluster analysis here and all sorts of different plots that go with that. I've got the results of sort of looking at some scatter plots and the parallel coordinate plot of all the data. So these are just three different routines I ran. They're all connected. So if I highlight data in one of these graphs, you see how that data gets highlighted everywhere, all pieces of output. Okay. So if I highlight, one of the clusters, cluster 1, that's being highlighted everywhere. Here I'm highlighting another cluster. See, now you can see those are the points that make up that cluster. They're being highlighted in that graph. They're being highlighted in this graph. They're being highlighted in this graph. Okay, they're being highlighted in this graph. So in JUMP, it's not just that inside of an output or inside of a platform things are connected. They're connected across platforms. So if I had a regression analysis up here, for example, I see the points that are highlighted, the ones I'm highlighting, the residual plot of what I'm doing. So it's really cool. It's not just that they're all connected within a platform. They're connected across platforms. Something else you can do is, if there's certain data you don't want part of your analysis, so let's say, for example, you don't want Atlanta, let's say you don't want some of these cities that are in the southeast. I'm just clicking on a couple cities here in the U.S. that are in the southeast. If if you don't want those a part of your analysis, you can highlight them and then basically say, okay, I want you to hide and exclude those from the analysis. So now you'll see a new symbol gets added next to those rows. And so now if I go forward and do an analysis, those 5 rows aren't excluded. Okay, and then I can shut that off if I want. I can also do it by, if it's something's more complicated than just highlighting data, I can bring up this data filter and start defining it. So I can say, okay, I don't want to include any data where this value is greater than 20. Okay, so I can put that there. Okay, and see how things are starting to get highlighted. And then I can keep on adding things. Oh, I want it when these values, oh, actually I can switch that around here. When these values are between, 50 and just kind of making some stuff up here. So you see that as I'm going through this data filter over here, that hide and exclude concept is getting added over there. Okay, and I can just keep on filtering by stuff. Okay, so you can build up what you want as a set of categories, and then that allows me to say, okay, now this is how I'm subsetting the data. And then I can save that, this data filter to the data table. And then if I go back to the full data set, where nothing is hidden or excluded or highlighted, and then whenever I want to launch that data filter again, I just launch it and I've got those highlighted. So what this allows you to do is from one data table, create a variety of subsets that you then work with and just launch it whenever you want to do some kind of analysis to exclude or include certain specific sets of data. So you don't have to actually make another data table if you don't want to. You of course could if you want, but you don't have to. All right, I'm going to close this guy up here. All right. Let's do a couple quality examples. Since you guys are in the engineering world, so you probably see a lot of quality control, process capability. Okay. So here's a data set. It's just measuring the diameter on a part, and you can see that we have different days. So you've got a set of measurements here on day 1, then a set of measurements here on day 2, and a set of measurements on day 3, and so on. So just like the graph builder, we have something called the control chart builder. So the control chart builder is just waiting for me to drag in variables into the different roles. So if I grab diameter and drop it into the Y, notice it basically said, okay, well, you just dropped in a single variable, so I'm going to create an individual and moving range chart. Now, I happen to have spec limits attached to that column, so it instantly did a capability analysis too. If I didn't have, let me show you what that is. So inside of this column, I basically have a set of spec limits defined. So if you have spec limits attached to a variable, if you do a control chart, then the capability analysis comes along automatically. If I didn't have those there, then we wouldn't see that at all. So in this case, we saw it. Okay. Now, this is doing an individual moving range chart, but if you go back to the data, you say, well, we actually have this data in subgroups, right? So we've got day 1 has 6 observations, and then day 2 has 6 observations, and day 3. So maybe a different way to look at that is not as an individual and moving range chart, but as a mean and, say, range chart. So if I bring in day and grab it, and notice we have all the drop zones, then I can just drop day into the appropriate drop zone, and then jump automatically says, oh, okay, you must want an X bar in our chart because now you have subgroups. And so now the top control chart is an X bar chart and the bottom one is a range chart. And I can change those. Maybe I want, instead of a range chart, maybe I want a standard deviation chart, and I can swap out that, and now the bottom one's a standard deviation chart. And again, there's all sorts of ways that I could kind of tweak this graph a little bit. This is the classic one showing the, the green, yellow, red when you're at different, standard deviations beyond the center line. You can add that, and all sorts of options exist. And same thing, you drop down the red triangle. Now all your options related to control charts will pop up there. If you go over to the capability analysis, well then dropping down those red triangles, that's where they all are. Okay. I'll actually pull that up one more time here. The other thing you might have noticed in the data set is there's two different phases that are going on during the collection. So there's phase one, and then after a certain point of time, there's phase two. Okay. So if I grab that variable phase, there's a drop zone right up here for me to put it in, and as soon as I put it there, it says, okay, well then you must want a pair of control charts, one set for phase one and one set for phase two, and it makes those individually, or I can pull this down. So what's nice about this is you're not opening up like a dialog box where you have to fill it all out correctly and put everything in the right places. You sort of you're building it as you go, and so that just allows you to sort of drag something in to see, that's what I want, or drag it out, I don't want it there, or maybe I want a standard deviation chart instead, so I can change it to that. Maybe I want a moving range chart, I can make it that. So you're kind of playing around with it to get to the particular piece of output that you want. Now, for those of you that are teaching capability analysis in your classroom, what is the best way to explain what capability is? Start changing things and watch how the capability values change. So here's this interactive capability plot we have. Okay, so here's the fitted distribution. It's got the spec limits, the target. It's got all the capability metrics over here on the right. And now I can start moving things around. So I'm going to move around the upper spec limit. And as I move that around, you can see all the capabilities values changing. Okay. Maybe I just want to move around the mean of the distribution. And here you can explain to the concept to the students of how much the distribution can shift around before the out of spec conditions get too great. I can start changing the variability in the distribution, going back and forth, shifting the mean, changing the spec limits. I can make all those changes, and you can watch how all the capability metrics change. Okay, I want to bring up another data set to show capability analysis, where I want to show doing a capability analysis on many variables at the same time. Okay, so I've got 6 different variables here, 100 observations on each. Now, you can do an individual capability analysis one at a time, But what's more interesting is when you can look at this all dynamically together. So I'm going to launch JMP's process capability platform. I'm going to put all the variables in there. Click OK. And what JMP does is it's trying to display all the capability of each of those processes, but together so you can compare. Now, I'm going to just first show all the individual ones before I get to that combined output. So here's all the individual capability analyses. So here is the capability analysis for process 1. And I'm just going to close them up as I go. Okay. Here's the analysis for process 2. And again, under the red triangles are different options, but I'm just going to keep on closing. Here's the individual capability analysis for 3. You can see this one isn't that great. Huge amount of variation outside the spec limits. Here is 4. Well, it's just kind of barely making it in the spec limits. Here's 5. So 5 has really nice variability, small relative to the spec limits, but the process is shifted, right? So it's not on target. So that capability isn't great. So I'm just looking at these individuals. So here's 6. That looks like a really good one. Low variability, right on target. Okay. So now what JMP does is let's combine all of that information for those 6 processes together. And so it makes this graph here, which is showing the variability on the y-axis standardized to the spec limits, and then where it is relative to the mean, again, standardized to the spec limits. So now everything's on the same scale. And so here's a graph of each of those processes, so I can look at both location and variability at the same time and identify things like, oh, here's process 3. And notice when I float over, a control chart pops up for it. So here's process 3. It's on target, right? It's kind of in the center, right at 0, but the variability is huge, right? And when we looked at those individuals, pop that one down again. Here's capability 3, right on target, but notice how massive that variability is relative to the spec limits. So that plot's very high up on this graph. This process down here is process 6, right on target and very low variability. Just going to open that one up again. We saw that. Process right on target, very low variability compared to those spec limits. Okay. Now, process like this one here, which is number 5, it has low variability, but it's plotted way over to the left. It's not centered. And I can open that up to see if you remember that one, right? The variability was decent, but it's shifted over to the lower spec limit. And then it actually standardizes all the data so you can look at it actually as as box plots, and again, showing how that all compares to the center and the spec limit, but all standardized and scaled so that now you can compare them. They're not, different processes. Now we got them all on the same scale to look at. Now I can see the PPK value, which is a capability metric for those who aren't familiar with it, which is just sort of a measure of how good that process is to spec limits. And so now I can kind of see, well, which ones meet different capability values, right? I can do the same thing up here too. This one's a plot of PPK, which is another metric. So I can define some PPK value that I want the process to meet, and then I can see which ones meet that level. So it's showing me like a region that meets that criteria. Okay. So JMP does this concept across a lot of platforms where it doesn't just run one analysis; it can kind of combine it all together. And now you can basically see not just one thing at a time, but its relationship across many variables. In fact, let's let's maybe finish up with this one because this is a big data set, so you really get to see kind of the strength of JUMP here. All right. But before I move on to this last example, just any questions before I move on?
Yep. One question in the room.
Is there a possibility that if the combination can be clicked in one side other than for all?
Is there, what do you mean the combination?
The combinations of the different capabilities. Like instead of only choose capability 1, 2, 3, or if there's only one capability only one.
Is there a way to combine, the question was, looking at capability, you had capability for each of the processes. Is there a way to combine all of that data into one metric, say 6 processes, calculate the capability of these 6 processes versus these 6 processes? Is that right?
Oh,
Yeah.
well, we have that overview plot I was showing you where you can kind of compare them to each other. But if you wanted to put stuff in a multi-dimensional sense, we can sort of get at that with some multivariate control charts, which might be what you're addressing. Well, that's going to be just more of a control chart assessment. Other than the multivariate platform, I don't think you're going to be able to reduce that down to just one number. I have to think about that a little bit.
Okay, no problem. Thank you very much. And this is a time check. We've got about an hour before we have to get going.
Okay. All right. So I'm picking up just trying to grab just a really big data set here, where there are 123 rows, and there's 108. Sorry, there's 108 rows and 123 columns. Okay. So this data set happens to be measurements that were made on stents. So a stent is a little object, and it's got all these dimensions you can measure. The distance between this this piece and this piece, or the dimension between this distance and this distance. So this is a data set that was collected across these 108 stents, and there's 123 different dimensions that can be measured. And so here's all the data. It's all standardized, and so now all on the same scale. But pretty big data set. And you can see, as you look at it, there's places where there's some missing values. You can see some of those spots there, right? Well, JUMP has a couple neat tools to just get a sense of where the data is missing. Okay. So I'm going to launch a little platform we have that's called Missing Data Pattern. Okay. And I'm going to put in all of those variables. Hit OK. And JUMP creates this table. Okay. And what it's basically doing is it's looking at every possible combination of where there's missing values or no missing values. Okay. Now, the way this is interpreted is this first row, where it says 42, the count is 42. It's basically saying there's only 42 rows that have nothing missing across. One of the rows, well, actually, let me pick something where I can, well, we have so many. This thing is long because there's 123. But this will show you that, okay, there is one row that has a missing value, and we'd have to scroll through to find, it's a missing value for dimension 111. Okay, so there's one row that has a missing value at dimension D111, okay? There are 32, I'm just picking another one, there are 32 rows where there's one missing value in the 6th dimension, okay? So this is just a way to take a data set that's got all these missing values and just summarize it for you. So I can just see where they're missing. You know, that, right, for example, that's interesting to know that there's 32 missing values in that dimension 6, right? That, in fact, that's the one that has the most, if you look at it, that's the one that's got the most missing. There's some reason for that, right? Now you can kind of quickly see that. So this is just a little summary table that shows you, summarizes that, where that missing pattern is. But there's another way to look at this that is even more interesting. Is put all the variables in there. Okay. So it makes this graph, and you're like, what? You're thinking like, what is that? Okay. Think of this as basically the data table. There's 123 columns and 108 rows. And it's like standing back at the data table, and anywhere there's missing observations, there's a black hole, okay? So now you can actually look, is the missing data just kind of randomly spread around in the data, or is it occurring in certain areas? And you can see this isn't random at all. In fact, this column right here, that's column 6. That's where we saw all those missing values in column 6. But look at this right here. There's this whole region right here where there's just so much missing values across all the dimensions. Now, you know, why that is, I don't know, right? If you were working on this data set, you might figure out, oh, during that time we couldn't make all the measurements, or there was another issue going on, and so or something was wrong with one piece of equipment, or whatever it is. But we're seeing that. And then there seems to be a bunch that are kind of up here. You know, what are all those dots up there for? And then there's nothing missing down here. So this is now a visual way to see where the data is missing. And so what's neat about this is if you start sorting the data or grouping the data in different ways and then seeing how that pattern looks, you might, for example, notice like, oh, the data is missing mostly around when this value is very large, or it happens to be missing the most on these days, or it happens to be missing the most during these operators. And so it's just kind of a quick way to sort of get a visual of the missing data pattern to hopefully kind of learn something about your process just from that. Now, it's one of those topics, missing data, when I was in school, wasn't talked about a lot. I mean, they certainly brought it up that, oh, data's missing, and when you get out and work, you're going to see a lot of missing data. But they didn't spend much time in the classroom talking about it and talking about how to deal with it. But this technique of looking at the data, I think, is very useful. In addition, let's see. I don't know if you're familiar with these techniques, but I can actually use JUMP to estimate those missing values. So it sort of basically interpolates like what might be missing. So I can actually ask JUMP to go in there and it basically went through, and you see all those blue cells. So by basically looking at that data in a multidimensional sense and all those variables together, it can kind of estimate what those missing values are. Now, it's obviously not really the value, but it's a way to get a complete data set because you can sort of impute what those missing values might be. And it's very useful for like model building, building prediction models, because it's pretty common that you've got a data set where there's very few rows where there's a complete set of data. And most statistical techniques, they kick that row out if they don't have a complete set of data. Like if you try to run a regression if there's an observation missing, it's going to kick that whole row out. And so what's common out in practice is you try to run a regression model. You think you have 10,000 observations, but there's only 50 that are complete. And so techniques like this, where you have to like estimate or impute the missing values, is really common out in the real world, because you got to preserve how much the data that you have, and you don't want to throw out a whole row just because you're missing one observation. And the logic being, well, it's when it comes to prediction, it's sort of trying to hit on average what that value is, and you're like, well, maybe it's not harming the prediction too much. It might be overstating the precision, but at least it might not be creating a biased prediction. So it's a common technique, and JUMP has some ways to do that. So I just kind of imputed all those missing values. So now I have this complete data set, 123 columns, 108 rows. So any technique I do won't throw it a row. Another thing you do with data is you try to look at you try to get a sense of are there any unusual values or any outliers. So I can go here and let's see, do a three-dimensional. I can go here and do a 3D plot. Okay, so here's a 3D plot of all the values. Okay, and again, there's a lot. Think of how many possible combinations there are of 123 variables. So I can just start clicking through them. If I want to start looking at it this way, seeing when there's some unusual observations. Okay. But this is a highly dimensional problem. So maybe a more interesting way to do this is JUMP has a routine to try to look for outliers in a multidimensional sense. And there's a couple techniques JUMP has. One of them is called this k-nearest neighbors concept, where it starts measuring how far each data point is from its closest neighbor, or does it its closest two neighbors, or its closest three neighbors. And so there's a couple up here, and I'm just going to zoom one up just to show you here. Okay. So basically, this is just the distance every observation is to the next closest observation. And so, for example, if I highlight these points up here, they're the furthest ones away. And let's see, I can pull up. I want to pull up a graph that has those on there. Bring up that scatter plot again. Okay. So these points up here are the ones that are the most unique. They're the furthest away from the cluster of points. So now again, this graph has a 123-dimensional problem reduced down to one dimension. Over here on the left, I'm looking at a scatter plot, and so you can kind of see where those points are. Now again, the scatter plot is only 3 dimensions at a time, not 123, but it shouldn't surprise you that you're starting to see the ones that are on the edge of, in that 3-dimensional sense, are corresponding to the ones over here. I'll just make it red so it's easier to see, right? Okay. And so I'm kind of clicking around and kind of getting to a sense of where those large observations are. And again, I might choose to clean them up, or I might choose to just maybe look at them more closely. Now I'm going to pull up. I want to look at, let's say,
Hey, Kevin, are you?
Yep. Oh, can you hear me? Oh, can you hear me at all? Oh, can you hear me? I might have lost you.
And identity service calling. If you are expecting this call, press 1. Your verification ID is 9160091. Your verification ID is 9160091.